Okay, so yes, this is fourth grade math. I don't care what anyone says. Maybe not the division. Shh. I'm online now. All right. And, you know, those that had me in CAT, first of all, I'm sorry. 2 years in a row. Uh, it was big to understand fraction rules because the graphing calculator or regular calculator wouldn't help you to do fractional stuff that didn't have numbers, which was all over the place in the curriculum. So you needed to know these ideas anyway. And plus, it makes me sad that you have to type it, then hit the math frac button, when actually this one's very fast. Do I get a common denominator for this one? Yes or no? Do I get a common denominator for that? Yes or no? No, and those get convoluted all the time. Okay, again, just raise your hand if you got. I'm not, come on. Common denominator is this, and this is how this is so much faster than opening up your calculator, turning it on, typing the fractions like a robot, and then copying the answer after hitting the math frac button. 10 plus 3 is 13 over the common denominator, 15. How many people got that answer? Don't raise your hand because you didn't write anything yet. I thought you were going to... Oh, you have all my... You do have everything I've said so far. Oh, never mind. I thought you were writing all the things I said. All right. Now, you don't get a common denominator, but don't... Go ahead and multiply with multiplying fractions. What can you do to make it easier? Cross, not multiply, you're killing me, Smalls. Thanks for playing, though. Cross something. Cross, it's actually cross cancel. How many times does 4 go into 8? Twice and once. How many times 5 go into 15? 1, 3. Don't tell me that's hard. Then you multiply across. 1 times 1 is 1. 2 times 3 is 6. This is 1 6. So if you read the stuff at the top, when you're doing probabilities, a lot of times, which is the chapter, we're in chapter 10, probabilities. Probably should have announced that. You're going to deal with these fractional situations. And then baloney. If this is written on a test, this is exactly what you should do. What is the common denominator? By the way, what's the denominator of 1? 1 over 1. Common denominator, 8 and 12. Don't go 8 times 12, 96. Find a smaller one, which is 24. You didn't do that, I'm just saying. So what do you multiply this one by? 3, top and bottom. This one is, I just like crossing it off and just making it 24 over 24. And then this one you multiply by 2. And then you can do this real fast. 5 times 3 is 15. You add the numerators. 15 plus 24 is 39. Minus 2 is 37. All over the common denominator of 24. Another way you could write this is 1 and what's left over and 24 goes into 37? 13 24ths. Fractions, 4th grade math. You okay? Student passed out. How about when you divide fractions? What do? My cat students, meow, know what to do. 3/5 what? Times what? Times the reciprocal of 2/3, which is 3/2. Then you can go ahead and cross cancel, can you? Nope. 3 times 3 is 9/10. Wasn't that fun? Okay, yawning, oxygen. So do we have to do this one? You know what? I don't care. I am going to do this one because it makes me sad when people try to type this first one in the calculator when they actually make a mistake probably if they don't use a fraction button. Inspires and some 84s can do a fraction button. Where all I would do is this. What would I change 1 to? 7 over 7. 7 minus 2 is 5. You can get you a chance to write this down. And then what actually happens? The 7s actually cancel because they're both in a denominator. Or if you don't like it, you don't trust me, you multiply by the reciprocal of 5/7. That's how you change. This is division. This is a division symbol right there. To divide a fraction is to multiply by its reciprocal. Boom, boom. Yes, the 7s do cancel. Next one, this is just a PEMDAS. Isn't this fun? I feel like this is just like great teaching. How you doing? What's PEMDAS mean? Parentheses, exponents, multiply. Let's stop there. Boom, boom. Okay, anything cross cancel? No. This is high school? No, it's 4th grade. What's this end up becoming though? Always good. Anyone on YouTube, I just blew out an eardrum. No one's listening. No one watches. It's fine. Okay, always do what? Reduce. So what does this reduce to? Come on. If you don't know that, you get out. Okay. Now, could this be no calculator? This is probably pushing a little bit. We went through a long progression. Fourth hour. Let's do it. I heard someone say, yeah, let's do it. They said the exact opposite, actually. 500 over. 500 over. 1. 1. 1. This is not a minus sign. This is a negative times a positive. Okay. Annoying. At least 8 and 500, what goes into them? You can at least do something. 2. Oh, does 2 go in again? 2 times what equals 250? And now you at least broke this down to be manageable. Sorry. What's 3 125s? 375. Those are like, what? Take a minute. 3 times 100 is 300. 3 times 25 is 75. 375. Blah. Does 16 go into 80? Yes, it does. Actually, what would be easy is maybe divide them by 8. Oh, and then... But you know what? What's this denominator right here? 2. And aren't I going to have to add these anyway? I might just want to leave it 70 halves. Because if you make this 2, 1, and 5... Then you get 35. Then you have to change 35 to 70 halves anyway. So we're going to eventually have to subtract these. And then explaining this, is it longer than actually typing this on the calculator? Yeah, but if you just worked on it, I think this would be smaller. Except for this one. This is annoying. Oh, I know 4 goes into these. Because 4 goes into 12 how many times? 3, right? So this is negative 300 when you put a 4, take a 4 out of that. Right? That's easy. Don't tell me that's difficult. And then does 4 go into 300? Sorry, let's take a 2 out. And then this is negative 150. Now I got it manageable. Plus 3 times negative 150, 300 plus 150 is what? So negative 450 over 2. Then you can go ahead and add these. This is negative 75 plus 70 is negative 5 halves. Boom shakalaka. There's your 4th grade thing. Maybe the negative's 5th grade, 6th grade. That's what I did because, I don't know. When I try to figure out what do I want to teach, I do read the sections. This book's really good at explaining. And I just pulled out some keywords that you might want to write down to start off. Yes, we're doing 10-1. Probabilities and simple experiments, possibly. We'll talk about, first thing, like the difference between experimental probability and theoretical. Okay, you could do an experiment. The outcome of the experiment is what we're looking for. The sample space is all the possibilities. So be aware of that word because it's in your homework constantly. Write the sample space. By the way, I have a gift for you. All right, let me hand out the gift. And then an event. The event is usually like what you're looking for. So say you roll a dice. How many sides are in a standard dice cube? 6. Labeled 1 through 6. And then what's the probability? This is easy. What's the probability you roll a 4? Everyone should know this. You have a 1 out of 6 possibilities. So 6 is the sample space. There's 6 possibilities. The event of rolling a 4... That's what we're looking for. That's called the event that you're trying to have happen. Just a word that's probably not too important, for you to think about or memorize. Okay. So here's the gift that I gave you. This I made it so it was small, so less trees killed. This is actually your sample space for one of our examples, plus your homework assignment tonight. And it's good that this is from our Algebra 2 book. I'm still in denial that someday we'll teach out of that Algebra 2 book again. But never mind. Don't worry about that. Who took Algebra 2? Yes. All right. This is if you roll 2 die. Actually, that's what they're called when it's plural. 2 die. What are your possible outcomes? This is your sample space. When you roll 2 die, there's only one way of getting a 1 and a 1. So that's 2. You might have to rotate this when you look at it. I thought that'd be nice. And then piggyback that off with our vocab word there. And then notice the sums of 7. Just count that real quick, or not. How many sums of 7 are on your paper? How many different ways can you get a sum of 7? This is what the game of craps is based off of, because the sum of 7 is the most amount of outcomes that could happen. How many did you count? Should be 6. It's that whole diagonal when you go down. 1, 6, 6, 1 is different because there's different colors, different ways to get 1 and 6, either white, red, or red, white. I'm reversing that. But the other thing is this. In teaching Algebra 2 back in the day, there are students that have never played cards before. So yes, they don't know that there's 52 cards in a deck. They don't know in a standard deck that there are 4 whats? What are those called? Suits. Diamonds, clubs, spades, and hearts. The diamonds and the hearts are red, because sometimes they ask some probability questions. How many red cards do I get? Or like, what's the probability of getting a red card? If you don't know what a deck looks like, you can't answer these questions. So it's happened in the past. We're not making fun of you, but if you've never played cards, then how would you know what a deck of cards standard looks like? Now, there are different games that have different decks. Pinochle is a completely different deck. Really, like poker, which we'll do a whole gambling unit, and we'll figure out how to beat the house. No, I'm just kidding. You'll never win. Actually, I'll do that right now. Don't gamble. It's set up for you to lose. The longer you play, you will lose. And then you'll end up being broke and losing all your money and destitute and then living in a van down by a river. There's your gambling lesson. Okay, now, switch gears. Okay, the first one I decided to, are you okay? I say we're starting to lose you. All right, the first type of probability is actually called, what we're mostly probably going to do is theoretical. You're actually not going to do an experiment, but you're going to talk about the likelihood of something to happen if we were going to do it. So what's the probability I flip a coin and I get heads on the coin? 1 out of 2. All right. What's the theoretical probability that I get heads on a flip 5 times in a row? Well, now, if you sit there and flip a coin 5 times in a row, is it likely that you're going to get heads 5 times in a row? Now, that problem I just showed you, we'll figure out how to do later. It's very simple, actually. It's 1 over 2 to the 5th, because you take 1/2 times 1/2 times 1/2 times 1/2. This and this and this and this and this have to occur. But blah, 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 blah. We're not actually flipping the coin. We're talking about what is likely to happen because of the probability of the event happening. Hey, guess what? This is from our grand old Algebra 2 book. Again, in denial, I wanted to pull a picture that I knew was in there that actually tells you what's going on. This is just, okay, here's the sample space. 1, 2, 3, 4, 5, 6, 7. Did I count that wrong? 8. I think I counted that wrong. So there's 8 possibilities. This is the success, what you're looking for. So 3 out of 8 is the probability for this random thing that they put up there. Whatever. For our purposes, you could either get heads or tails. That's your sample space. The probability of getting heads is 1 chance out of 2 possibilities. Very basic, very simple. You don't have to write all that verbatim. It's overworded. Don't do that because we won't have the time. This is basic. You should have already done it. You did this in either the Math 2 or Math 3 class. I didn't do it in Math 2 2 years ago, so I'm assuming it was Math 3 you did probability. Anyone have anything to say about that? Alrighty then. You did it in Algebra 2. Where were you in? Last year. Did you do it in Math 3? Huh? You don't remember anything from last year? Shut it all out? Had you brainwashed to get all that? Never mind. Ah! Okay. Now, I have the screen frozen, I think, on the internet. This shows. But now we're going to do an experiment, but we're not. It does say the word experiment. An experiment consists of tossing 2 fair coins. Find the theoretical. So are we actually going to do it or not? No, we're not actually going to do the coins. Okay, probabilities for each outcome for E. The event of getting ahead on the first coin, and the event of getting at least one head, period. It doesn't say on the first or second coin. So here's what you had to do, the sample space. I flipped 2 coins. Tell me all the possible outcomes. I could get what? Head, and then a head on both of them. Then what? I could get what? Head, tail. But what else could I get? Tail, head, and then what else could I get? Tail, tail. So how many possible outcomes are there? 4. Then if you talk about the probability of each event happening, the individual probabilities are 1 out of 4. Now, these are the possible outcomes. Writing all the possible outcomes out is called the sample space. And then this is, we could figure this out later, actually use this to answer a question. What's the theoretical probability of each case happening? Now what you got to understand is this is one question, so I'm going to call that letter A. The event of getting ahead on the first coin. How many ways does that happen in our list? How many ways does it happen where I get ahead on the first coin? 2. And there's 4 possibilities overall. So again, this is Mickey Mouse probability, piece of cake, no problem. One thing I will say is you can put probability as a decimal or as a percent to make people understand that scenario as well. Are you okay? Yes. Like LTHS, huh? Nice. All right, B. What does it mean to get at least one head on this roll of flip of 2 coins? That means I get one or less or one or more. Come on, somebody. 1 or more. So how many possible ways does that happen? 3. Least you good over there? 3. Nope, apparently not. Okay? No. All right. 0.75, especially during my video. Okay, and then the difference between that and what's called experimental probability. You shouldn't even be writing any of this down, right? Experimental probability is actually doing an experiment and then collecting the data, actually flipping the coins. What you'll find that it's not likely, like if we set up a theoretical probability on what's the probability of doing this, does it match the experimental probability? As you're writing this down, how can dice, a 6-sided dice, be set up to not work nicely that, we get each one's 1/6 possibility of rolling a number? The dice could be what? Loaded. A loaded die, which happened a lot back in the old times, is a die that's heavier on one side or the other. So it's going to fall to the heavy side, so the opposite number is going to happen more than anything else. So that's something that's maybe listed in the book as well about, having a fair die or fair coin, making sure you don't have something illegal. Obviously. Here's the experiment of tossing 2 coins. The exact same thing we talked about theoretically happening. And if this matched, look at the chart only before you start writing. If this matched the theoretical probability, what should all of these numbers actually be? Think about it for a second as you start writing the notes. What should all of those numbers be if it matched the theoretical probability of what should happen when you toss 2 coins and assess if you get heads, tails, tails, heads, 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 tails, tails? 125. See? Now you feel good, even though you were nervous about getting knocked down. Why should it be 125 if it matches the theoretical probability? Because all of these should happen 1/4 of the time, right? And there's the idea difference between theoretical and actually experimental. It won't always, but if you did more of these, then it might start falling into line more. Like if you only did like 24 tosses, or flips, then more than likely will be not close to 1/4 for each one of the probabilities. All right, but as you do more and more, it gets closer and closer to that, I'm sure. If the coins are loaded, I don't know how you get a loaded coin, but then you might have a problem. So let's look up here, and then I'm going to add a question so you know how to answer something that's in the book here. Okay, so let E be the event of getting ahead on the first coin. Find the experimental probability of E. You can't say 1/4 anymore. This was an experiment where you wanted to find out what is the probability of getting ahead on the first coin, which is how many times? What plus what in this little experiment? Head on the first coin? Give me one of the numbers where you got head on the first coin. 137. What's the other one? 115. And what's the total amount of flips that we had? 500, actually. There's a 500 total flips on this. So that's the difference between experimental and theoretical. They don't always match. In fact, they hardly ever match. If you actually theoretically did something and then actually did an experiment to test it out. But they should be close. So FATERMACT, I think this should say 250. If it matched theoretical probability, it's 252. Then I'd ask you to reduce, and you can reduce, and so on and so on and so forth, or make it a decimal. Now, according to this experiment, and it's not going to be worded this way, but it's tied. At letter A, they have an experiment that's done, and then you have to say what the probability is. I don't know how I worded it first hour. If we did 2,000 flips, what is the probability of E, which is the same event that I had up there? I'm just going to be lazy on the notes. What's the probability of getting heads on the first coin? Well, now we have to stick to the experiment and pretend that these coins, this is how it works. The coins are weighted in a way maybe that it doesn't quite go to the 1/4 thing. I don't know. So what do we have to do for that? Think about that for a second, then I'm just going to tell you the answer because this isn't a comic. Oh, you're so close. Why'd you say 137 though? Remember the probability of getting heads on the first coin. Oh, equals, right? We're setting up a proportion equals x over 2,000. That's what you do. Okay, now I know someone else first hour said, what could we do to 252 real fast? Not divide by 2. What's the relationship between 500 and 2,000? Multiply by 4. Okay, so there should be 4 times as many of these. But what if this number wasn't nice like that? Putting a proportion together is the way. Okay, then you solve that proportion by cross-multiplying. 500x, sorry for squeezing this in there, equals, I don't know. What's the matter? Multiply by 4. Figure that out faster. Okay, so it'd be 1,008 of those. Let's move on. I feel like I'm losing it. You lost me a hello. All right. Boom, boom. All right. Okay, so look at this next one. Okay, so you were supposed to read that during that time. So before I answer these questions, what's the sample space? Okay, so jar contains we draw 2 marbles. Now listen to this. 2 marbles from the jar, one after the other, without replacing the first one. Just remember that because there's a question in the homework where you draw it, then you put the marble back in, shake them up, and then draw again. Much different scenario. You need to think about that. Very easy. So what could we get? Well, we could get red and then what? Come on, just tell me. Red, then what? Green. Too late. Red, then what? Blue. There's no blue in there. Who said blue? Red, then what? Yellow. Too late. Red, then what? White. Or the first one could be what? Green and red. Green and yellow. Green and white. I'm actually ignoring them. Or you could do yellow, then red. You want to organize this and not get them all cattywampus and all over the place. which actually is a word. I think it just means off center. White, someone could Google that. So how many possible ways could this happen? How many possible ways could this happen? 12. Not red and red, because we're not doing what with the marble? Replacing it. Remember that, though, what you said when there was a replacement question. Red and then red would be a possibility that would, throw off what the sample space is by a lot, make it a lot larger. Okay, so what's the probability that one of the marbles is red? And it just says one, not at least one. So where do you have one red marble? How many ways does that happen? 6, actually. Out of how many? You get it. First marble, and then of course we make that 1/2. I'm not reducing anymore. I want to move on. First marble is red or yellow. Now, when you see the whole sample space, you can look at them and just count how many there are. You'll find out the word or in probability means add, though, later. But anyway, first marble is red or yellow. 1, 2, 3, 4, 5, 6. It's again 6/12, which is 1/2. Marbles are the same color, not without replacement. Without replacing, there's no possible way of getting both of them to be the same color. With replacement, that would change the game. The first marble is not white. How many times do you get not white as the first marble? It's 9 out of 12, which is 3/4. And then blue, maybe that's why someone said blue. There's no marbles that are blue. So probability of getting blue is 0. All right. The other class I was going to have that question be answered. I'll just have you think about that. I pulled 14 out just so that you would read it to make sure, and you could probably figure this out without me, but it goes through this whole long diatribe of how you're supposed to do 13. I'll just do 14 using what they say here. One way you can construct a sample space if there's two different weird things, like this one. Construct a sample space for the experiment of tossing a coin and drawing a marble, blue, green, and yellow in there. Okay, so you're doing both. Well, what are your possibilities for the coin? Heads or tails? This is how they tell you can do this sometimes. And then what's your possibilities for drawing out a marble? You could either get a what? Purple? Was it green? And then yellow? Just wanted to go in order that they were listed. And then what's the probability of you, when you do both, getting certain things? Well, you get heads purple, tails purple. You just line these up. Or you get heads green, tails green. Or you could get heads yellow, tails yellow. And I thought that was a good way of getting a sample space if you have something along these lines. So the sample space is 6 possibilities of getting this to happen, like whatever the possibilities are. So just whoopsie daisy. Neither marble is blue. Just change the game. Play baseball, right? Gotcha. So you drop a thumbtack. All right, now I'm not doing this one. This is the point of, what is this, experimental or theoretical? This is experimental. You did the experiment. You're dropping tacks. You got nothing better to do. All right, so you're dropping tacks. Ooh, it pointed up. Ooh, it pointed down. All right, 42 times up, 42 times down. Or 18 times down. Got too excited. All right, so what's the probability it's pointed up? What do? 42 out of, come on, class. Oh my gosh, I'm going to kick a table. 42 out of 60. And then you reduce. Pointing down, 18 out of 60. But then, based off the experiment, what if you did it 100 times? What do you set up? It starts with a P and ends with proportion. Proportion, because I don't have the time for you not answering questions. It's easy. This is grade school math. All right, now go back to your gift that I gave you today. Because there are a few questions, few questions in the homework that deal with the rolling to standard die. And I gave you the sample space. There it is in front of you. How many possible, or what's the sample space? How many outcomes do you have when you roll 2 dice? How many different ways can something happen? So it's the sheet that I gave you over there. 36, right? And there is a difference between getting a 1 on the white and a 2 on the red, or a 2 on the white and a 1 on the red. There's 2 different ways of getting a 3 with 2 different dice. Okay? There's 2 different ways of getting a 5 and a 2. Right? And so on and so on and so forth. So, when you get to those questions and it asks you to write the sample space out, you're supposed to write all 36 of those possibilities. Don't. I gave it to you. So I hope you're listening. Some won't even do it anyway, probably, but just saying that's what it's going to, when it comes to a test and I ask you write the sample space out, you're going to have to write the sample space out in some way, shape, or form that makes sense. And if you don't, you get no points. That's life. Okay, so what's the probability of A? Well, what does A say? Probability of A getting 7 dots. That means a sum of 7. Look at your cheat sheet. Look at your sample space. How many times do you get 7? It's 6. It's very easy. That's why the game of craps is based off of rolling a 7. It's the one that most happens. So it's 6 out of 36. 1 6. Very basic. What's probability of getting B? A sum that equals 8. I think it's only 5. And does this reduce? No. Then just understanding that there's a way to do this one. What does it mean to get at least 4 dots or a sum of 4? 4 or what? 4 or more. What's actually smart to do is how many times do you not get that happen? And then it's the opposite of that. So how many times do you not get a sum of 4? 3. So that leaves how many for a sum of 4 or more? 33 out of 36. So I'll say that one more time. There's a whole bunch of them for a sum of 4 or more. So I find out the probability of the opposite of that. The remaining is what actually the answer is. So there's 3 that are not a sum of 4 or they're less than 4. 1, 1. And then the 1, 2 and the 2, 1. So it's 33 out of 36, which is 3 goes into 33. 11, 12. So I got it. Let's lock it down.